So this equation is like mainly for like bigger objects, I guess.
Yeah, I mean, it'd be really strange, like they could do it, they could say, what's the gravitational pull between this table and the dry erase marker? But it'd be something times 10 to the negative 15 or something like that. It'd be such a tiny, tiny little force that it doesn't do anything, you know.
Gotcha.
Sometimes in the morning, the pull of gravity from your bed to you is a lot stronger, but I don't know how that works. I don't know the physics behind that. So this proves that this is gravity on Earth. So what they'd actually probably end up have you doing with this kind of a problem, or this equation, would be saying, well, here's the Earth, and over here's the moon. So find the force of gravity from the moon to the Earth. So then you do this. Distance from Earth to moon, not to Martin, to moon. And this is stuff that you could either look up, or sometimes, like the book has a table that has some of this stuff in it. But the distance from the Earth to the moon is 384,400 kilometers. And then we need the mass of the moon. Mass. The mass of the moon is 7.348 times 10 to the 22nd kilograms. Okay. So, gosh, just ruined my marker. So if you were told to find the force of gravity from the Earth to the moon, how would you find it, knowing all that?
The distance or the mass?
Well, you want to find, how much the Earth pulls on the moon due to gravity.
Okay. So M1 would be, I guess, the Earth's mass.
Right. So this would be mass of the Earth.
And then M2 would be the mass of the moon.
So you have 5.972 times 10 to the 24th.
Over 384,400 kilograms squared.
So let's go from kilometers into meters. Just because, so a Newton is 1 kilogram meter per second squared. So it's best to be, like, this is in kilograms, this is in meters cubed over, so you want to be in meters for this. So anytime you're working with forces, the units you want to use are kilograms, meters, and seconds, because those are the ones that are in a Newton. So you then take that, and it's just calculator stuff from there. So you'd say 6.6738 times 10 negative 11 times 5.972 times 10 to the 24th times 7.3 3, 4, 8. Oh. 20 seconds. Divided by 384 squared. Screwed that up somehow.
You put something like a -11 or something.
Yeah, so G is to the -11,
Oh,
6.6738 times 10, -11 times oh, okay. No, that's probably right. So it ends up being pretty huge. I don't know why I was wanting it to be pretty small, but this ends up being 1.98 times 10 to the 20th. That's how much force the Earth is exerting on the moon to keep it in orbit. So let's see what this says. Force of the yeah. Yeah. Okay. So yeah, it'll be about that. You don't need to use this very often though, honestly. I mean, you talked about it today, but you might have to use it in a couple of problems and that's it.
Okay.
I guess there's one other thing that it could be. If you wanted to find out the force of gravity on the moon, so we won't do this one, but say you're on the moon. Let's see. You're on the moon, you're standing on the moon, mass of 70 kilograms. You wanted to find out how much gravity, what the force of gravity of the moon was on you. How would you find that?
On me?
Yeah.
Well, I could have found the gravity of the Earth, I guess.
Yeah. So what would you plug into your equation? G you know already.
So do M1 would be 70 kilograms.
Uh-huh.
M2 would be, I guess, that'd be the mass of the moon
Yeah.
over the radius of the moon squared.
Yeah. So you can do that with any planet, figure out what the mass, figure out what the mass and the radius are. And you can just put somebody on that planet and see how much gravity would be. So. But like I said, you use it for a couple little problems like that, but then not much after this section. make sense how to use that equation though?
Yeah, it does.
It's pretty straightforward, just plug in the things you need.
So is that what G always stands for? 6.6738?
Yeah, pretty much. I don't think there's any time that. Yeah, that's just a gravitational constant. It's something that Newton figured out. And it works, it's correct.